Hello, this is Eric with Easy Science. Science explained as simply as possible. In this video, I'm going to be talking about seasons. I think if you went to the northern hemisphere somewhere, to Europe or to the USA, and asked a lot of people, why is it that it's warmer in the summer and cooler in the winter, a lot of them would say, well, we're closer to the sun in our orbit in the summer and we're further away in the winter. However, if you look at this diagram, you can see that's not actually true. In fact, the opposite is true. In the summer, we're actually further away from the sun. We're at the furthest point away from the sun. And in the winter, we're at the closest point to the sun. Now, this particular diagram is exaggerated. There's actually only a small difference. But still, we are actually a little bit closer to the sun in the winter and a little bit further from the sun in the summer if you live north of the equator. So as you probably know, the Earth does spin. It rotates from east to west, and of course it makes one entire rotation in the course of 24 hours. And as this happens, the sun is actually hitting the Earth. And in some places it's hitting the Earth more directly than in other places. So in some places, such as near the equator, sunlight is hitting the equator directly, and so as a result, the equator is the warmest part of the Earth on average. And then other parts that aren't on the equator are receiving less direct sunlight, where the sun is kind of glancing off of the Earth in those places. So summer is happening to the part of the Earth that is receiving the sun's rays most directly, and the opposite portion of Earth is experiencing winter because it's getting the least direct sunlight. And so the distance doesn't matter so much during our orbit as far as the seasons. It's more important to see, is your part of the Earth getting direct sunlight or indirect sunlight? Furthermore, this first picture that I showed you is incorrect. We wouldn't have seasons if the Earth was kind of rotating while sticking straight up and down at a 0-degree angle. This is not what's happening. If this were the case, then simply all year long, the center of the Earth, the equator rather, would be getting roasted with the most direct sunlight all year long, and this would just be a barren desert. At the same time, you would have the poles getting constantly frozen all the time and getting hardly any heat because the sun's light would just be barely glancing off those parts of the Earth. And so all humans would only be able to live in a tiny little strip of land halfway between the equators and the poles, and that would be the only place people could live. So in reality, the Earth does not spin facing straight up and down, if you will. It does spin along the North and South Pole. It does rotate along this axis, but it's at an angle of 23.5 degrees, which means that the sunlight is not directly striking the equator during most times of the year. It's striking the Earth at an angle. And if you're wondering, well, which part of the Earth then is receiving the most sunlight, the answer is it depends on the time of the year. So this 23.5 degree angle is constant throughout the entire year, and this means that depending on where you are in relation to the sun, certain parts of the Earth are receiving more direct sunlight during different parts of the year. So if you look at the globe on the right, this represents the summer in the north. So if you're in the USA, this might represent June or July, and at this point, the northern half of the Earth is tilted at 23.5 degrees toward the sun, which means that the northern hemisphere is receiving more direct sunlight. And at the same time, the southern hemisphere is tilted away, which makes it winter in the south, while it's summer in the north. Then if you go all the way over to the left side, 6 months later, you can see the opposite is happening. The northern hemisphere is pointing away from the sunlight, and as a result, it's getting very indirect sunlight. Sure, the Earth is a little bit closer to the sun by a few million miles, which sounds like a lot. It's not that much. But more importantly, the north is facing away from the sunlight and just getting glanced by the sunlight. So if we add these dates, you can actually see the 4 times of the year in which the days are either the longest, the shortest, or most equal. So the date at which the northern hemisphere is tilted most directly toward the sun is on or about June 21st. Some years it's June 20, about June 21st. And this is called the summer solstice. This is the point in which the north is the most pointed toward the sun that it will ever be during the course of the 365 days out of the year. Because you're pointed more directly toward the sun, it basically allows the sunlight to wrap around your part of the earth a little bit further than any other day. And so this is the longest day out of the year. Now, if you're in the southern hemisphere at this time, though, then that means that your part of the planet is actually facing further away from the sun and as far away from the sun as it ever will face throughout the year. And you have the shortest day of the year. In fact, if you're down in the South Pole during June 21st, this might mean that you don't even have sunlight at all on that day. In fact, maybe no sunlight for weeks on either side of June 21st, because you're pointed so far away from the sunlight that you're in shadow during the entire day. So the other solstice is December the 21st, and so this is the shortest day of the year when you're pointed the furthest away, further north, for people in the USA and Europe and China, for example. And then for the people in the south, say in Brazil or in Australia, this is summer for you. So this means that you're pointed most directly toward the sun in the south, and so it's the longest day of the year. It's summer for you. So then you have these two other dates called equinoxes. Now the word equinox is like a mashing of two other words, equa meaning equal and nox meaning night. So equinox means equal night. So what you're going to be seeing there is that this is the day in which you are not pointed toward or away from the sun. Okay? At this point, the sun is actually shining on these days directly on the equator. And so both north and south hemisphere receive an equal amount of daylight, an equal amount of nighttime. So it should be 12 hours a day and 12 hours of night. So now you know what causes Earth's seasons. It's Earth's tilt. Be glad of that tilt, because without it, much less of Earth would be inhabitable. As I said before, whole chunks of Earth would be baked all year long or be frozen all year long, and this allows people to live on most parts of Earth. And so while you're freezing your butt off in the middle of the winter, be warmed by the thought that wherever you are, somewhere on the opposite side of the Earth, is a person enjoying the warmth of summer on a beach. This has been Eric with Easy Science. If you have enjoyed this video or it's been useful to you, please like and subscribe. And in the meanwhile, I hope you have a great day.